Hi, my name is Dr. Adam Manley, and this is Session 3, Basic Math for Plumbing and HVAC Technicians. The agenda for this session is as follows. We're going to talk about integers, labeling, fractions, mixed numbers, decimals, changing feet and inches to decimals, and scale rulers. Integers are whole numbers that can be written using the numerals 0 through 9. As well as their corresponding negatives, -1 through -9. Even though they can be positive or negative, integers are numbers that can be written without a fraction or decimal component. These integer numerals are the building blocks for forming larger numbers. The table 4-1 above here illustrates the concept of position. The headings are in order of magnitude, starting at the right and proceeding to the left, with each position increasing by a factor of 10. This system has no limit, because no matter how big or small a number you write, it is always possible to write a bigger or smaller number. Any number can be expressed in terms of this system. For example, the number 843 is read from the tables as 800 plus 40 plus 3. Leaving out the word plus, the number is more accurately read as 843. Labeling an answer is essential to show the complete answer to any problem. The label identifies the units in which the answer is given. There is a big difference between 21 feet and 21 inches, so labeling clarifies that length. Mixed numbers are whole numbers and a part of a whole number. The part of the whole number may be expressed in fraction or decimal form. So some examples of mixed numbers would include 24 and 1/2 inches, 187 and 3/4 feet, or 5.2 miles. Fractions are especially useful in measuring. A plumber needs to take measurements for rough-in and finish work, repair work, and service work. The majority of fraction work in the plumbing trade involves measurements made with a measuring tape or with gauges. Fractions are used to indicate a portion of a whole number. For this reason, a fraction consists of two numbers with a line that separates them. The number below the line, called the denominator, indicates how many parts of the object is divided into. The top number, called the numerator, indicates how many of those parts there are. For example, 3 is the numerator, 4 is the denominator. We typically say that this is 3/4. Most plumbing work involves fractions of halves, fours, eighths, and sixteenths, which are the common divisions found on a measuring tape. A fraction should be expressed in its lowest term, which means that it might need to be reduced. A fraction may be reduced if both the numerator, the top number, and denominator, the bottom number, can be divided by the same number. In the case of measuring, this normally means that the top and bottom number can be divided by 2, 4, or 8. For example, the fraction 4/8 can be reduced because both the numerator and the denominator can be divided by 4. When each number is divided by 4, the end result is the fraction 1/2. So another example is if a fraction was 7/8. 7/8 can't be reduced because there's no number that divides evenly between both 7 and 8. Commonly used in the field are improper fractions. If the numerator of a fraction is larger than its denominator, so let's say 3 seconds, the fraction is called an improper fraction. An improper fraction is not incorrect, but it's harder to visualize than its mixed number equivalent. To simplify an improper fraction, divide the numerator by the denominator to get the whole number and a remainder. The remainder will be placed over the denominator to represent the fraction that remains. Let's talk a little bit about adding and subtracting fractions. First, in order to do this, it's a three-step process. One is have to express all fractions in the terms of the same denominator. You then have to add or subtract all numerators and set over the common denominator, and then simplify the result if possible. So rather than try to explain this, let's watch a video.
G'day and welcome to the Tech Math channel. In this video what we're going to be having a look at is a way of adding two fractions together or subtracting two fractions from each other where we have different denominators, different bottom numbers. So I'll show you how to do this. It's a really simple method. And this is the way I usually show my students at school. It saves a lot of hassle. So say for instance we have a fraction like this, a half, and we want to add to that a third. To do this really simply, this is what we do. Okay, so we hit equals and I'll put that line there. And what we do is this. To get the bottom number first off, what we do is we multiply these numbers. So 2 times 3 is 6. Pretty easy, yeah? And then what we do is we start at the top left here and we multiply this number by the diagonal here. Okay, so it's diagonal bottom number here. So 1 times 3 is 3. We use the same sign as which is a plus. Then we go over to the right number here at the top and we multiply this number by this number. 1 times 2 is 2. Okay, equals 3 plus 2 is 5. And we've got the bottom number as a 6. And there you go, we've got 5, 6. That's the easiest way of doing these, okay? So anyway, I'll put another one up. Hopefully you got that one. Alright, I'll get another fraction. What about we go something a bit different? We'll go 1/4 and I'll put, what about something like 2/3? And that equals, alright, let's have a look. I'll get this pen here and again, we'll work out the bottom number. We multiply these. 4 times 3 is 12. We get this number here, the top left, and we multiply it by this number, which is a 3. Use the same sign, multiply this number by this one, okay? 2 by 4 is 8. 8 plus 3 is 11 over 12. Yeah, you get that? Alright, I reckon a few more examples, because we'll go do a few subtraction ones in a minute. Also, you'll notice with a few of these, they're at their most simple, and so a couple of these you can simplify a bit further. Let's have a look, we'll see if we can get one. So what about if I add 1/2 to 3/4? Hopefully this will work. And what we do is, again, you might give this one a go before I start. Yeah, you might have paused it and given it a go, hopefully you did. So what we do is we go 2 4s are 8. Start at the left. It's really important you start at the left, by the way. I'm not starting over here, I'm always starting over here, you'll notice. 1 times 4 is 4. We use the plus. 3 times 2 is 6. Okay, so 4 plus 6 is 10. And then we get 10/8. Now what you're going to notice first off is that we can simplify this further. So let's do this. First off, we look for a number that goes into both the top and the bottom, and you'll see straight away that number is 2. So we divide the top by 2, we get 5. We divide the bottom by 2, we get 4. We can still simplify this. This is at the moment what we call an improper fraction. We can turn it into a mixed number, that is. And the way we do this is we go 5 divided by 4, because if this top number is bigger than the bottom number, you can do this. 5 divided by 4 is 1, and 1 left over. We put that 1 over the bottom number, which is 4. Okay? I reckon another one. Okay. Hopefully these are not a problem, and hopefully you're picking them up really easy. I must say I've always wondered why they teach fractions really difficult. I often get a lot of students come in and they've done fractions 3 or 4 times in their school career and they still don't get it, and it's actually a little bit annoying. Yeah. So anyway, I'll shut up and I'll keep going. So what about we do 3/4, and we multiply. We're not going to multiply. We're going to add that to a third. All right, what does that equal? Get the bottom number. 3/4, 12. Start up here. 3/4 are 9. We go plus. 1/4 is 4. We end up with 13. 3 plus 4 is 9 plus 4 is 13 over 12. That we can simplify further because we have this number here is bigger than this number, and then so we divide 12 into 13. 12 goes into 13 once, 1 remainder, 1 over 12. Okay, what about if we start with, we could do the subtraction one. Okay, what about that? We do 3/4, take away, what about a third? Okay, it's the same sort of thing, and this is where it becomes really important that you start in a second, in this top left in a little bit. So first off we go 4 3s are 12, and this is where this bit becomes important. You start over here, 3 3s are 9, use the minus, 1 4 is 4, 9 take 4 is 5, this goes over 12. We have our answer. Now, just one little variation on this, by the way. I think this is a good thing to get, but I might even, I won't be able to do this straight away, but I'll put a link up to this, and this is where I'll be looking at how to, if we get a question that looks like this. Say we have something like 1 1/2, and we add that to 2 1/3, okay? And you're going to notice now, I'm not starting with simple fractions, I'm starting with mixed numbers, okay? And we're going to be adding mixed numbers. Mixed numbers are where we have a whole number and a fraction together. So the way we deal with this is we have to turn these into what is known as improper fractions. This is a fraction where the number on the top is bigger than the number on the bottom. And the simplest way to do that is you get this number, you times it by this number, and you add to this number, and that will give you the number on the top. I'll go that again to get the number on the top. This times this plus this, so 1 times 2 is 2, plus 1 is 3. The bottom number stays the same. The plus stays the same. Again, same process. 2 times 3 is 6, plus 1 is 7. And then the bottom number stays the same. And then we treat it like we were before. Okay, bottom number. What about we use red for this? Bottom number, 2 3s, 6. Okay, we do these ones, 3 3s and 9. We put the plus there. 7 2s are 14. And then what we do is we add these guys together, 23, and we put that over 6. Now, as you'll see again, this number, this is an improper fraction. This number is bigger than this number. So if we go 23 divided by 6, because this line here means divided by. 23 divided by 6 goes 3 times, because 3 6s are 18. We have 5 left over. 5, and we put that over 6. I hope that was of some help. Anyway, we'll see you next time.
Okay, let's talk a little bit about the same procedure that we use in fractions, but there's one minor change when we add and subtract mixed numbers. While the last video talked about it, here's another video showing you how to do it.
Hey guys, it's Julie with Mahalo.com, and today we're going to talk about adding or subtracting mixed numbers. Now, in this case, it happens to be subtraction, but all the rules are the same if it were an addition problem. So, let's start with a way that you can do it to where you can do these problems the same way every time and not get it wrong. For example, some people think that you can just do 3 minus 2 and get 1, and then do 1/3 minus 1/4 and get whatever that fraction is. Now, in this problem, something like that would work, but it won't work every single time. Because if this fraction is smaller than this one, you'll have to borrow from that whole number. So here's a way you can do it, and you do every problem the exact same way, and you're guaranteed to get it right. First, we need to turn these mixed numbers into just fractions. And we know how to do that by saying 3 times 3 is 9, plus 1 is 10, over the same denominator. And over here we have 4 times 2 is 8, plus 1 is 9, over the same denominator. bring down our subtraction sign. We also know that the rules of adding or subtracting fractions is you have to have the exact same denominator. These aren't the exact same, so we need to get what's called a common denominator. So how do they become common? If they were 12. So how did I turn this 3 into a 12? I multiplied it by 4. And remember, what you do to the bottom, you need to do to the top. So we're going to multiply that times 4. 4 times 10 is 40. What did we do over here? How did this 4 become a 12? Well, we multiplied it by 3. 4 times 3 is 12, and 9 times 3 is 27. So now we have two fractions with a common denominator, so now we can subtract. And you remember that the rules of adding or subtracting fractions is you leave the denominator the same, and you just subtract or add the top. So in this case, we're going to subtract. So 40 minus 27 is 13. And we also know how to turn a fraction into a mixed number. So this 13 would reduce to 1 and 1 over 12. And that's how you add or subtract mixed numbers. Thanks for learning with me today. If you liked what you saw and would like more information about related topics, click on the links below. And if you have specific problems or requests, email them to requests@mahalo.com. See you next time.
Now that hopefully you have a better understanding of adding and subtracting fractions, let's talk about multiplying fractions. So essentially what you do when you multiply fractions is that you multiply the numerators, you multiply the denominators, and then you reduce the fraction if necessary. Let's watch a video.
Hey guys, it's Julie with Mahalo.com, and today we're going to talk about multiplying mixed numbers. Now, even though this problem looks a little bit intimidating, all we're going to do is turn these mixed numbers into fractions and then follow the multiplication rules we already know. So, in this case, to turn it into a fraction, 5 times 1 is 5, plus 3 is 8, over the same denominator. And in this one, 3 times 2 is 6, plus 1 is 7 over 2. And we know the rules for multiplying fractions are simple. You just multiply straight across and then reduce. So here, 8 times 7 is 56, and 5 times 2 is 10. Now, on most tests or quizzes, teachers are going to ask you to reduce completely. So we would want to turn this fraction back into a mixed number. So I'm going to bring it down here. 56 over 10. We're going to turn this one into a mixed number. So how many times does 10 go into 56? 5 times. And 5 times 10 was 50. So now we need to take that 50 away from that 56. So we're going to subtract. 56 minus 50 is 6 left over, and we always use the same denominator. So now while it's in a mixed number and that's correct, is this reduced completely? No. So you're going to want to reduce this fraction further in order to probably get the answer correct on your test. So we bring down the 5, and we're going to reduce this. What number goes into both 6 and 10? That's 2. So we're going to divide the top by 2. 6 divided by 2 is 3. And we're going to divide the bottom by 2. 10 divided by 2 is 5. So our final answer to this problem is 5 3/5. And that's how you multiply mixed numbers. Thanks for learning with me today. If you liked what you saw and would like more information about related topics, click on the link.
Now let's talk a little bit about dividing fractions. Division of fractions is performed by inverting the divisor and multiplying. The divisor is the number that follows the division symbol. To invert is to turn something upside down. In other words, to divide a fraction, the divisor is flipped over and the equation is then multiplied to get the result. If a whole number appears in the equation, it can be converted to a fraction by simply giving it a denominator of 1. For example, the number 12 can be expressed as the fraction 12 over 1. Additionally, any mixed number must be converted into an improper fraction. Let's watch a video to understand more about dividing fractions.
Hey, this is Julie with Mahalo.com, and we are going to talk about dividing fractions. Now, dividing fractions can be very intimidating because most people don't love fractions and they don't love dividing. Put it together, it can feel like an intimidating problem, but I'm going to show you a trick that can make it easy. We're going to divide 2 over 7 divided by 3/4. And while this looks like a scary problem, the trick I'm going to teach you makes it very easy. I need you to remember the acronym KCF. And what that stands for is keep, change, flip. So you're going to keep the first fraction as it is, 2 over 7. You're going to change this division sign to multiplication. And you're going to flip the last fraction. So if we flip 3/4, it's going to turn into 4 over 3. So anytime you're dividing fractions, anytime, you're just going to turn it into a multiplication problem, and then it's simple. Because when multiplying fractions, you just multiply straight across. 2 times 4 is 8, and 7 times 3 is 21. And you can't reduce that fraction, so there's your final answer. Thanks for learning with me today. If you'd like
Decimals are fractions that have a denominator that is a multiple of 10. 10, 100, 1,000 as an example. One number to the right of the decimal indicates a tenth. For example, the decimal 0.3 is the same as saying 3/10. Likewise, two numbers to the right of the decimal indicate 1/100. The decimal 0.82 is the same as saying 82 over 100, or 82 100ths. To determine the value of a decimal, the first consideration is its position after the decimal point. A decimal with a higher value in its first digit is larger than a decimal with a lower value in its first digit. Thus, the decimal 0.74 is larger than the decimal 0.53. If the numbers in the first position after the decimal point are the same, the second number should be compared. This carries through to each position after the decimal point until a higher number is determined. It is also important to note that adding a 0 to the end of any decimal does not affect its value of the decimal. For example, 0.4 is the same as 0.40 or 0.400. Often in learning math for the plumbing trade, you will hear the term decimal places. This term is used to indicate the number of digits after the decimal point. For example, 2 decimal places means to answer the question with just 2 digits following the decimal point. Adding more decimal places implies that a higher degree of accuracy is needed to complete the work. To add or subtract decimals, the critical factor is to line up the decimal points before starting the math. So you'll notice in our illustration here that all the decimal points have been aligned. If a decimal place is blank, it is implied a 0. Now when it comes to multiplying decimals, the multiplication of a decimal is like the multiplication of any other number, except that once the calculation is complete, you must determine the correct location of the decimal point. To determine the correct location of the decimal point, count the number of digits after the decimal point in both numbers and add them together. Then, in your solution, count that many digits from the right to the left and insert the decimal point after that last digit. So you'll notice in our example, the first number has 2 decimal places, the second number has 1. You complete the calculation as if those decimal places don't exist. You come up with your number, and then you count up the number of decimal places, and for this one there were 3 decimal places. Dividing decimals is division with decimals is also like division with whole numbers. However, in order to get the right solution, the decimal places are moved to the right in the equation by the number of decimal places in the divisor, the number you're dividing by. So here's an example.
So now we will be going over dividing decimals. here we have 31.773 being divided by 5.1. So let's set this up using long division. We have 31.773 on the inside being divided by 5.1. And the one thing that you have to remember, and I wrote this for you in green, you have to get rid of the decimal in the outside number. So we have an outside number of 5.1. We need to get rid of this decimal in the outside number. So basically we have to push this decimal point as far right as possible. In this particular example, we only can push it over one space. And whatever you do to the outside number, you have to do to the inside number. So since we moved our outside decimal one space to the right, we have to do the same thing to the inside decimal. So now, since we moved both decimal points one space to the right, our 5.1 becomes a 51, and our 31.773 becomes 317.73. So 31.773 divided by 5.1 is exactly the same as 317.73 divided by 51. So now I'm just going to give myself a little bit more space and erase this on the top. And I'll move this a little farther up. So now that we got rid of the decimal in the outside number, we can just divide this using normal long division. So let's just get started right away. 51 goes into 3 0 times, since 51 is bigger than 3, so we'll move to the next digit. 51 goes into 31 0 times, since 51 is bigger than 31, so we'll move on to the next digit. 51 goes into 317, how many times? Well, we know that 50 goes into 300 6 times, so I'm going to guess that 51 goes into 317 about 6 times. So now if we multiply the 6 times 1, we get 6, and 6 times 5 is 30. And if we subtract the two numbers, we get 7 minus 6, which is 1, and 1 minus 0, which is just 1. And I'll bring down my 7. So 51 goes into 117 how many times? Well, we know that 50 goes into 100 2 times, so I'll guess that 51 goes into 117 about 2 times. And 2 times 1 is 2, and 2 times 5 is 10. So 7 minus 2 is 5, and 1 minus 0 is just 1, and bring down my 3. And before I go any further with this example, I want to place our decimal point. Our decimal point just needs to move straight up, so it goes directly in between the 6 and the 2. So now how many times does 51 go into 153? Well, we know 50 goes into 150 3 times, so I'll guess that 51 goes into 153 3 times as well. 3 times 1 is 3, and 3 times 5 is 15. So 153 minus 153 is 0. So we have a remainder of 0, which means that we can stop. So now we divided 31.773 by 5.1, and we have a final answer of 6.23. So here are some more videos with some more example problems related to the video you just watched. I really hope you're finding my tutorials helpful. So until my next video, I will see you.
Now let's talk about converting decimals to fractions. To convert a decimal to a fraction, write the decimal as the numerator of the fraction. The denominator will be a 1 followed by as many zeros as there are digits to the right of the decimal point in the numerator. The fraction can then be reduced to the lowest. Terms. The required operations can then be performed according to the methods of fractions. Let's watch a video on converting decimals to fractions.
let's see if we can write 0.15 as a fraction. So the important thing here is to look at what place these digits are in. So this 1 right over here, this is in the tenths place. So you could view that as 1 times 1/10. This 5 right over here is in the hundredths place. So you could view that as 5 times 1 over 100. So if I were to rewrite this, I can rewrite this as a sum of, this 1 represents 1 times 1/10. So that will literally be 1/10 plus, and this 5 represents 5 times 1/100ths. So it would be plus 5/100ths plus 5/100ths. And if we want to add them up, we want to find a common denominator. The common denominator is 100. Both 10 and the least common multiple, both 100 is a multiple of both 10 and 100. So we can rewrite this as something over 100 plus something over 100 plus something over 100. This isn't going to change. This was already 5 over 100. If we multiply the denominator here by 10, that's what we did. We multiplied it by 10. Then we're going to have to multiply this numerator by 10. And so this is the same thing as 10 over 100. And now we're ready to add. This is the same thing as 10 plus 5 is 15 over 100. And you could have done that a little bit quicker just by inspecting this. You would say, look, my smallest place right over here is in the hundredths place. Instead of calling this 1/10, I could call this literally 10 hundredths. Or I could say this whole thing is 15 hundredths. 15 hundredths. And now if I want to reduce this to lowest terms, we can, let's see, both the numerator and the denominator is divisible by 5. So let's divide them both by 5. And so the numerator, 15 divided by 5, is 3. The denominator, 100 divided by 5, is 20. And that's about as simplified as we can get.
Percents are a particular way to express a decimal value. Percentages can be used in the calculations in decimal or fractional form, but they are normally used as decimals. A percent is converted to a decimal by removing the percent sign and moving the decimal places 2 places to the left. So here are some examples. 62% in decimal form would be 0.62. 18% would be 0.18, and 125% would be 1.25. So here's an example. A contractor pays $65 for a stainless steel sink. The contractor sells the sink to a customer at a price that is 55% above his cost. How much is the sink markup? What is the total cost to the customer for the sink? So you would look at the base, which is $65 for the sink, and the rate, which is 55%. Therefore, we're solving for the final cost, which we'll call P. So using a formula P equals B times R, what we can find is we can find what the markup would be. 65 times 0.55, that's 35.75. So we then add the $65 for the base of the sink. We add the markup, which we've now calculated to be 55% the cost of the $65 sink. That's $35.75. And so the customer is charged $100.75 for that sink. Now let's talk about changing feet and inches to decimals. Dimensions in feet and inches are much more complicated to work with than those that are in decimal form, regardless of whether they are made by hand or by using a calculator. To change inches into a decimal of a foot, divide the number of inches by 12. Why 12? Because there are 12 inches in every single foot. So, here's an example. What portion of a foot is 3 inches? Well, you would take the 3 inches, divide it by 12, because there's 12 inches in a foot, and it equals 0.25, or 0.25 inches. When we talk about scale rulers are measuring devices calibrated so you can measure a length of a drawing or blueprint. We talk about this in session 6. The use of a scale ruler reduces the chance for error and greatly speeds up the measuring process. By making a drawing to scale, the designer makes a diagram of the diagram of the item being represented at a smaller size, so it's more economical when it comes to drawing. Scale rulers are available in several types: architect scale, mechanical engineer scale, civil engineer scale, and metric scale. In construction work, the most commonly used scale is the architect scale. Some of the scale markings on an architect scale include the following: 1/16 inch equals 1 foot, 3/32 inch equals 1 foot. So why is this important? In order to produce the actual building product, the technician must measure the drawings and convert to full size. Using a scale ruler is the easiest way to do this. This is also the way most jobs are taken off project drawings. So here's the final example. A pipeline on a drawing measures 2.5 inches long. The drawing is marked at 1/4 inch equals 1 foot. So how long is the pipe? Well, you would take 2.5 inches, divide it by 1/4. You would multiply your fractions, and then you would get to 20/2 equals 10. Therefore, the pipe is 10 feet long. I hope that this math session has helped you. The next step is for you to go and study this PDF, watch the video as many times as necessary in order for you to understand the concepts, and when you feel ready, take the math quiz. Good luck.